Number 44 on the Math 110 final exam review says, for the following rational function, find the coordinates of the x and y intercepts, the equation of the horizontal and vertical asymptotes, and then graph the function. All right, so we've got y equals 2x minus 8 over x plus 2. All right, so x and y intercepts. First of all, x intercepts are when y is 0. So that's when you set the function equal to 0 and solve for x. Now for a rational function, when you set it equal to 0, the first thing you're going to do is multiply both sides by the denominator to clear that denominator. And so that cancels. So what you end up with is 2x minus 8, the numerator, equal to 0 times anything is still 0. So if you want to remember it that way, to find the x-intercepts, you really only have to set the numerator equal to 0 and solve for x, because a fraction is equal to 0 precisely when the numerator is 0. So that's usually pretty easy to solve for x. Here we don't even have to factor. We can just isolate x by adding 8 and dividing by 2. So we have an x-intercept at the point 4, 0. X is 4, y is 0. For the y-intercept, that's where x is 0. So plug 0 in for x. And what you'll see you always get, because the x terms go away, is just the ratio of the constants. Negative 8 over 2 is negative 4. So this has a y-intercept at 0, negative 4. X is 0, y is negative 4. All right, for vertical asymptotes, what you want to look for is a break in the domain, which is where is it undefined? That's where it's going to have a vertical break. And that's where the denominator is 0. So for this function, that would be x plus 2 equal to 0. And solving for x, you get x equals negative 2. An equation of a vertical asymptote is always a line, x equals some number. The intercepts, of course, are points. The asymptotes are lines. Horizontal asymptote, you look at what case you're in. If the denominator has higher degree, like if this was an x squared down here, then the horizontal asymptote would be the x-axis, because it would get closer and closer to 0. Y equals 0 is the x-axis. But this one, the degrees are the same. So what happens as x gets really, really large, which is what the horizontal asymptote is talking about, the end behavior, is these constants become insignificant. Think about plugging in 1,000,000 for x. You get 2,000,000 minus 8 over 1,000,000 plus 2. I mean, that's pretty much just 2,000,000 over 1,000,000, which reduces to 2. So, and that happens when x is negative too. So the horizontal asymptote is y equal the ratio of the leading coefficients, which is 2 over 1 in this case. 2x over x reduces to 2. All right, so that's the horizontal asymptote. So then to graph it, what you want to do is show all these key features, right? Y equals 2 is the line that crosses the y-axis at 2. So you will show that as a dotted line. X equals negative 2 is the line that crosses the x-axis at negative 2. That is the set of all points that have x-coordinate negative 2. And the x-intercept is 4, 0. And the y-intercept is 0, negative 4. So then what you want to do is either plot some more points or use your calculator, which is what I would suggest, to help you graph the rest of it. It's got to go through those points and it's got to approach its asymptotes. So let's see what it looks like here. Type it in. Make sure you put your numerator and denominator in parentheses. 2x minus 8 divided by the quantity x plus 2. And then you try a standard window, at least to start, zoom 6. And you can see it going through its intercepts and approaching that vertical asymptote and that horizontal asymptote. Some calculators try to connect the dots here, and so you'll see a vertical line there, but it's just your calculator connecting a dot up here to a dot down here. It's not technically part of the graph, so we always draw them as dotted lines. They're kind of like barriers. So to draw this in, then you would just want to draw the curve through those points, approaching the asymptotes. Up here, I probably should extend it a little bit. You've got a curve up here that's a similar type of shape to the one down here. And that's it.